Hello everyone. Let us discuss other reactions involved in aldehydes and ketones. First reaction is a Cannizzaro reaction. What is Cannizzaro reaction? Cannizzaro reaction and aldol condensation reactions are somewhat same, but aldol condensation reactions takes place in presence of a alpha hydrogen atom. There must be alpha hydrogen atom, but Cannizzaro reaction, aldehydes are aldehydes, not ketones. In simplest ketone also there will be alpha hydrogen atom. Aldehydes which do not containing alpha hydrogen atom undergo Cannizzaro reaction. That is, aldehyde do not containing or do not have an alpha hydrogen atom. Aldehyde which do not have an alpha hydrogen atom undergo self oxidation and reduction, self-oxidation and reduction on heating in presence of concentrated alkali. Okay, this is about a Cannizzaro reaction. So, in Cannizzaro reaction, what happens? Aldehydes which do not have an alpha hydrogen atom undergo self-oxidation and reduction. This is also called disproportionation reaction. Self-oxidation and reduction reaction. Here, one molecule of aldehyde, what happens? Undergo oxidation. That is, aldehyde on oxidation will give carboxylic acid or salt of carboxylic acid. And another molecule of aldehyde undergo reduction, right? Undergo reduction and give alcohol. This is about a Cannizzaro reaction. For example, C double bond O H or HCHO, right? Formaldehyde. We can write formaldehyde as a HC double bond OH or two molecules of formaldehyde. One molecule of formaldehyde in presence on heating in presence of concentrated alkali, that is concentrated potassium hydroxide, will undergo oxidation to give HCOO K or COO minus K plus potassium formate, right? Potassium salt of carboxylic acid, and one more is reduction product, that is CH3OH, right? One undergo oxidation as well as a reduction. We can write like CH3 C double bond OH plus CH C double bond O H. Here it will undergo oxidation, other undergo reduction. You can write easily here in alcohol. Here in carboxylic acid, one carbon atom is there. So in alcohol also there must be one carbon atom. So simplest one carbon atom alcohol is methanol, and carboxylic acid same. One aldehyde, in aldehyde here there is one carbon atom, and simplest one carbon atom aldehyde carboxylic acid or salt is formic acid or potassium or sodium formate. Easily you can write the products of Cannizzaro reaction. Okay, these two are or one more example I'll take, benzaldehyde, right? Benzaldehyde alone, there is no alpha hydrogen atom. One molecule of benzaldehyde reacts with another molecule of benzaldehyde, then in presence of concentrated potassium hydroxide, which on heating what we will get, as I said, one is benzoic acid COOH, and another molecule is CH2OH, right? Alcohol as well as acid. Then it results in the formation of oxidation product and reduction product. One is benzyl alcohol, another one is sodium benzoate. Next is electrophilic substitution reaction. In other reactions, first one is Cannizzaro reaction. These named reactions are very, very important. Okay. Second one electrophilic substitution reaction. So from first PO we are studying about electrophilic substitution reactions, right? You are knowing few groups are functional groups are ortho-para-directing, few functional groups are meta-directing. So if there is electron donating groups are present, then are ortho-para-directing. If there is electron withdrawing groups are present, then are meta-directing. So electron donating groups are ring activators and electron withdrawing groups are ring deactivators, right? Same way here, electrophilic substitution reaction, aldehydes undergo, or compound containing aldehydes or ketone functional group or aromatic ring. If in aromatic ring, if there is aldehyde functional group or ketone functional group or carbonyl functional group, these carbonyl groups are ring deactivators. Remember, hence these carbonyl groups facilitates incoming electrophile to meta position. Okay, it directs incoming electrophile to meta position. So if functional group ortho meta, here meta functional group, next is ortho meta para, here ortho meta para, right? To meta position, because these are meta directing group or ring deactivators because they are electron withdrawing, right? So benzaldehyde if we take, which on undergo nitration. Nitration is product nitrating mixture, concentrated sulfuric acid and concentrated HNO3. These are nitrating mixture at 273 to 283 Kelvin. What will get? As I said here, in nitration, NO2 plus is electrophile, right? It produces NO2 plus electrophile, and hence which the product of this reaction will be here C double bond OH, here ortho and here para, here it is nitro. Am I clear? This is about a electrophilic substitution reaction of aldehydes. Next, uses of aldehydes and ketones. Till here we studied physical properties, chemical properties of aldehydes and ketones. Now let us discuss what are the uses of aldehydes and ketones, right? First use is, these aldehydes and ketones are used in chemical industries. Both aldehyde as well as ketones are used in chemical industries. Why they are using in chemical industry? As solvents or starting material for the production of different organic products, etc. Okay. In the field of drugs, or drugs in the sense pharma, right? Pharma field, or in any other industries, they are used as mainly as a solvent or as a starting material for the production of other useful products. Am I clear? This is in a chemical industry. Second one is 40% of formaldehyde. Okay, diluted solution, not concentrated. 40% means dilute formaldehyde solution. 40% formaldehyde solution is called formalin. Is called formalin, which is used in biology labs to preserve biological specimens. Okay, to preserve biological specimens. Okay, clear it is. 40% formaldehyde is called formalin. They may ask, what is formalin? Formalin is 40% of formaldehyde, not 100%, not a concentrated one. Okay, dilute one. What is the percentage of dilution? 40%. Used in biological, in biology labs to preserve specimens. You might have seen in biology lab, right? And in the preparation of bakelite, this formaldehyde is used in the preparation of bakelite. Bakelite is nothing but resin of formaldehyde and phenol. Okay, phenol formaldehyde. Yeah. Phenol formaldehyde resin. Resin is called bakelite. And in the preparation of polymeric glue, that is urea formaldehyde glues and other polymeric product. Okay, that is urea formaldehyde glues. Next, fourth use is use of acetaldehyde. So acetaldehyde can be used in the preparation of acetic acid, ethyl acetate, or vinyl acetate, or many drugs. Okay, next is benzaldehyde. So benzaldehyde mainly used in perfume industry. Okay, mainly used in perfumery industry and also in the synthesis of other products. And also it is used in dyes. Next, acetone is a good solvent, hence it is used in industries and in the preparation of ethyl methyl ketone. acetone as well as ethyl methyl ketones are used as a solvent in industry. Okay. Next, we already discussed that is vanillin, butyraldehyde, camphor, etc. are known for their odor or smell, right? Hence they are used in the flavor, used to give flavors or in the perfumery industry. This is about aldehydes and ketones and uses of aldehydes and ketones. Mainly you must concentrate on bakelite composition, urea formaldehyde, glues, and bakelite is a phenol formaldehyde, and one more is a formalin, 40% of formalin. And also in perfumery industry we are using vanillin, then camphor, then butyraldehyde, etc. This is about aldehydes and ketones. Let us move to the next topic of this chapter, that is carboxylic acids. What are carboxylic acids? So carboxylic acids are nothing but organic compound or carbon compounds containing carboxyl functional groups, right? Carboxylic acids. Okay. What are carboxylic acids? Carboxylic acids are nothing but carbon compounds or organic compounds containing which functional group? Carboxyl functional group. Carboxyl functional group. Carbonyl functional group, that is C double bond O functional group. Am I clear? Carbonyl, aldehydes and ketones. Carboxylic acids are containing carboxyl functional group, that is COOH functional group. What is the difference between carboxyl functional group and carbonyl functional group? In carboxyl functional group, carboxyl nothing but containing carbonyl and hydroxyl. Am I clear? Carbonyl functional group and hydroxyl functional group, that is C double bond O carbonyl and OH hydroxyl. Hence the name is carboxyl, right? Carbonyl and hydroxyl functional groups. This carboxylic acid may be aliphatic or aromatic, that you are knowing, and that is aromatic carboxylic acids also there, or aliphatic. Carboxylic acid, or we can write it as RCHO, RCOH, right? Aromatic or aliphatic carboxylic acid also there, that you are knowing. And higher member of carboxylic acid, that is from C12 to C18, that is large number of carbon atom in carboxylic acids are called fatty acids, Okay. Now you are knowing about fatty acids and occur in natural fats, right, as esters of glycerol. Occurs in natural fats as esters of glycerol are called fatty acids, C12 to C18. Next, let us discuss about nomenclature and structure of carboxyl group. Okay, nomenclature and structure of carboxyl group. You already know the nomenclature, no need of telling from the beginning. Still, we'll brush up this nomenclature. Nomenclature of carboxylic acid. So, as we know, there are two systems of naming. First one is IUPAC and another one is a common system of nomenclature. Let us see common system of naming of carboxylic acids. How can we name carboxylic acid in common system of nomenclature? As we know, these names are derived from their origin or from sources or from places, right? And common name of carboxylic acids are ends with the ic acid. Ends with the ic acid. For example, HCOOH. The common name of this compound is formic acid. Formic acid, and the name formic acid, as we discussed earlier in aldehydes and ketones, this formic acid is derived from source, that is ant, from Latin word that is formica. Formica means ant, right? Formica means ant. And ends with the ic acid, formic acid, or CH3COOH. We studied this also, where in aldehydes acetaldehyde, acetum, right? Acetum means vinegar, right? Or sour taste, right? Acetic acid, that is derived from acetum, means vinegar, right? This is about a common name of carboxylic acids. Next one is butyric acid, that is CH3, CH2, CH2, COOH, that is butyric acid, that is name is origin from butyrum. Butyrum means that is rancid butter, right? Rancid butter is called butyrum. So common name of this carboxylic acids are ends with the ic acid. Now, what about IUPAC name? These are originated from Latin or origins from Latin or Greek words. IUPAC name of carboxylic acid. In IUPAC name, as we already discussed, the end E of alkanes are replaced by oic acid, right? IUPAC name, and E of alkane, and E of alkane is replaced by oic acid. Is clear? That is, for example, HCOOH, right? How many carbon atoms are there? There is only one carbon atom is there. Hence, parent group is parent chain. In parent chain, there is one carbon. Hence, it is a methane, right? Methane. And in IUPAC name, end E of alkane is replaced by oic acid. Hence, the name methanoic acid, right? Methanoic acid E is replaced by oic acid, right? or CH3 COOH. Here, how many carbon atoms are there? 1, 2. Hence, 2 carbon atom alkane is ethane. Am I clear? Ethane. And E is replaced by oic acid. Hence, name of this compound is ethanoic acid. Right? And what are other rules? Other rules we already studied in our previous year, right? And number of carboxylic acid are indicated by multiplicative prefix di, tri, etc. And position can be indicated by numbering, that is Arabic number, right? And if there is 2 functional groups, then we should follow one of the functional group is considered as a principal functional group. And if there is 2 carboxylic acid groups are present, then are named as dioic acid, right? These all rules we already discussed in our previous year. Let us see one by one. We'll discuss few more example. Okay.